Good morning, everyone. Welcome to the Subspace Developer Sync. Today, we're going to catch up on what everybody's been working on since our call 2 days ago. Let's see, Serge, you're first.
Okay, so yeah, I had a bunch of PRs submitted a few days ago, and so I was addressing comments on those from Nazar, and eventually it was merged. So the important PR was about processing parablocks from archive, and it's already in main. Another thing I was testing relayer on our environment in DigitalOcean, and overnight we had 90,000 logs, and then relayer stopped. But since we are not saving logs to any file, I just couldn't find the reason why. So I restarted it in the morning, and I think afternoon we had 240 something thousand blocks, and it stopped because of some heap allocation, like memory leak problem on the JavaScript side. So I posted error on Discord, and I will investigate a bit later what's causing it. And yeah, basically that's it on my side. There were some other minor issues. There was a farmer error. I also posted it in the thread. And I also noticed that when we are processing from archive, some blocks do not have any transactions. Sometimes we just skip like 3 or 5 blocks, and then next blocks have transactions. So this is something we have to investigate too.
Okay, great. Well, that's what we were expecting. We broke it. Now we just need to figure out what's wrong with it and fix it. For those 3 bugs or issues you described, have we created tickets for any of those, like in GitHub?
Not yet. I will create after all the calls.
Okay. So we've got one for the farmer. Is that should go to Ozgun, right, Nazar? Or should it go to you?
I don't think there was a problem with farmer. Or
was it with the substrate node then?
I think it's substrate node, yeah.
Okay. So let's assign that one to Nazar, and then the one about the memory leak, you've got that, Serge. Let's create an issue to manage it. And what was the third one again?
Some blocks didn't have transactions.
Okay. I guess assign that to yourself as well then. Okay. I feel like I'm having deja vu. Like 2 years ago, Nazar and I were writing Subspace in Node.js, and we ran into all of these memory heap allocation problems, and that was why we started writing it in Rust.
Okay.
All right, any questions for Serge? Okay, Liu-Cheng, you're up next.
Okay. In the last few days, I only submit a small PR to Subspace, that is to change the offset type of block object to a primitive U32. So just a small refactoring. And I spent most of my time on the decoupled execution. So yeah, this is on my side. And we had a call, and I have working on the document, something like that. And I spent some time to look into the substrate codes. Yeah.
Okay. Liu-Cheng, would it be useful for you and Nazar and I to have another call on Thursday or Friday to discuss this in more detail, or would you rather wait until next week so you have more time to do some
Yeah,
research on this?
yeah. Thursday or
Okay.
Friday is good.
Okay.
Good for me. Okay.
Great. I just don't want to lose any momentum here since we're having so much success lately with this. Okay.
Okay.
All right. Any questions for Liu-Cheng? Okay. Ozgun, you're next.
Okay. Phase 3 for phase 3B, to be precise, for farming abstraction is complete. I didn't move the ticket to the completed yet because probably in the pull request review there will be some comments or suggestions. So after that I will move it to the completed. I am working on the plotting. The only thing there is left to do is to not leave the plotting in an inconsistent state when I stop it. I believe block on option would be good for that. I'm open to suggestions. This is my current idea. Other than that, today I spent some time on this upcoming presentation and also review the things we have done in CUDA, especially for the supranational meeting as well. And this is how I spent my time from Monday.
Cool. I think we'll discuss the farmer stuff in the next call, but
Yeah.
Thanks for the update there. Any questions or comments for Ozgun? Okay. Leo, you're up next.
Yeah, yesterday I have been working in this Terraform repository. Basically I have tested all the infrastructure in a development environment and a testing environment. From the resources creation, I have automated the volumes creation, the attachment to the droplets, and the creation of a project, and it's all structured now in this development, testing, staging, and production environment. And I was basically testing all the commands from the beginning. When you launch these droplets, what are the dependencies, how to install Docker, a public RPC, how to create these certificates for the public RPC, how to run the farmer, how to run the relayer. And I also documented all this workflow, like I said, from the creation of the resources up to the relayer running in live mode and in archival mode. Because I was checking the Serge droplet and the commands he was using actually, and it's all working. I shared this repository, and I think that for now it's enough. And I finally integrated also this Datadog, and it's just one command actually, and it's really fast to integrate. I was really surprised because I just run one command with a Docker, actually with a Docker container, and it has a functionality to auto-discover all the Docker containers and automatically send all the logs from the farmer, the public RPC, and everything. And also it sends the standard output, so the relayer logs are available in the Datadogs also. So yeah, I think that's my main update. I tried to close this yesterday, and I was able to close it. So right now, after today meetings, I think that I'm going back to Subspace JS and start this storage API development.
Awesome. Sounds like great progress, Leo. For Datadog, is there some sort of login info that we need to share with the team so other people can get in and pull that?
Yeah, I created a free account and a Subspace organization. So yeah, I think that I can actually invite to your emails, guys, and yeah, I will share that.
Okay. Yeah, let's do that. And if you can create, add Justin to that as well and set him as like admin on that account.
Yeah.
And let him manage that password in Bitwarden, or ask him to manage that there. And then there's no problem at all with paying for that. Like if we want to upgrade to like the basic monthly plan, I don't imagine that's going to break the bank, and it would probably be useful, especially if we have multiple users. So you can just let Justin know that, let him know it's okay, and he's got a card. He can go ahead and set up a payment plan for that.
Sure, no problem.
Great. Any questions for Leo? Okay. Nazar, you're up next.
One update on the substrate node. I've finished my research on the different things related to palette vesting and tokens and everything. And that PR was merged. We finally have allocations in the code, which is nice. The second thing I was working is trying to optimize the performance of the relayer. Turns out it is heavily CPU bound. I did some tweaks on our side. For instance, we needed to hash the header, and we were decoding the header and then hashing it. But I wrote a simpler function which basically tries to figure out the length of the header, so you can just slice the array of bytes and then hash it without decoding it properly. That saves a little bit of resources and some other tweaks. I also did 3 pull requests to different projects. 2 of them are from the Polkadot.js organization. One is for development, like development-related configuration, which will allow us to have less polyfills in the code, especially on backend side, because that basically emulates some functionality of the Node.js, which is available natively, and that is also a performance overhead. For instance, private properties on the objects in JavaScript. The other update was to the Polkadot API itself. There are some things that could have been optimized, regular expression precompiles, also some data structure transformations. We're using different regular expressions and camel casing and stuff that actually happens all the time on the same exact inputs and outputs. So it was possible to memorize those calls and remove a lot of CPU usage there. Also did one pull request to like third-party library that Polkadot API depends on, because that was also in the profile and trace. I think the biggest consumer of CPU right now is actually the signing itself. And I believe it should be possible to create something like a worker pool and distribute signatures to those, instead of doing that all on the main thread. I think that is the next step that we should do. There is really not that much we can do beyond that right now. On my machine, it is able to produce between 300 to 400 blocks per second on the layer. So that's about as far as we can go on the one CPU core. And for signatures, it's actually using WASM. If it was like native with SIMD instructions, maybe it would have been faster. But they wrote the library in a way that is compatible with both browsers and servers. So that's probably something we need to live with. Yeah, I think that's all updates on my side.
Cool. Sounds like keeping busy as usual. I'm curious, would it be worth it to rewrite just the archiving from Genesis, or just the seeding of the relayer in Rust? Or is there a way that maybe there's a few critical components of that we could rewrite in Rust? Because there's like a Polkadot.js like equivalent in Rust. I know the front end relayer, or sorry, the back end of the real-time relaying would still be the same, but it seems like the bottleneck here is this seeding process. And I'm wondering if maybe there's a simpler Rust script we could write to do this. Just a thought.
Maybe. I'm not sure how simple it will be. We are actually reusing quite a bit of code between different nodes. We'll just have to rewrite a bunch of stuff. And at that rate, I'm not entirely sure how much CPU will save. I don't know what is the exact difference between WASM execution and native Schnorr signatures. Might be a lot, might be not very much. We'll see. I guess we can try. We should try to use worker pool just for signatures right now and see how much that gives us. If we can squeeze like 5x, that should be plenty for our purposes.
Okay. Could we do something like use like Neon and just have like just the VRF signature itself, like is something which we call down into like a Rust module for? Or
Potentially, everything is possible, but that increases the complexity of the layer significantly.
okay. Okay. Any questions for Nazar? All right. On my side, I worked on a specification for the decoupled execution that from the discussion Nazar and Liu-Cheng and I had yesterday. I've also been discussing the scalability design with Srivatsan, the horizontal scaling security aspects of that. Surprisingly, he thinks it's secure. And I'm going to be discussing that with Dr. Say next week. And otherwise, I've been preparing for the Substrate Builders milestone review, and then just the technical sides of the other financial things that are going on in the background right now. And I guess, Nazar, do you just want to give like a quick 1 or 2 minute overview of what you're thinking for decoupled execution right now for the team?
Yeah. So the basic idea is we want to split the work of creating blocks and running things that require a lot of state into 2 basically kinds of nodes. So executor nodes will store a lot of state about balances, smart contracts, and stuff like that. And farmers, for instance, will not have to deal with that. They will still have to like send transactions through them, but they will not care about processing them at all. The current working idea is to have something like runtime, which contains a blob of another runtime in it, so we can like atomically upgrade it. Somewhat resembles how Polkadot works, where they have runtimes of other parachains so they can validate blocks. So we'll have like a piece of logic separately there. And then we will, on executors, run actually 2 runtimes. One will be the regular one as everyone else runs, but we'll take that blob and run another runtime. And we'll send fraction, like some set of transactions which require a lot of state, and we'll run those transactions in that special runtime. So we'll kind of have like 2 consensus nodes, basically. So that inner one will depend on the outer one. And that way, executor will have ability to have 2 states. One is for the like main chain and one for these state heavy transactions. And we can then take a state root after running all the transactions and commit it back in execution receipt to the main chain. So executor will have ability to store a lot of state, but no one else will have to do that. And we'll still have like 1 main runtime where everything is canonical and where we feed the state root after execution. It's probably a bit hand-wavy how I explained it. There is a diagram on the Subspace protocol master board that tries to articulate it a little bit. It's called DeekX nested runtime. You can see roughly how it might work. Yeah, that's the idea in short.
Thanks, Nazar. Any questions on that?
So you said 2 consensus nodes. What does that
okay,
mean?
so right. So when we have 2 runtimes, the way runtime in Substrate works, you will have to run certain extrinsics, and then you have some state changes, and those state changes are combined together and result in a new state root. In order to receive state root, we need to have some boundaries. We have to have a block after which we get the state root. So there should be some kind of block production on that other runtime. So we have boundaries between those bundles of transactions. So that's why I say it's kind of like consensus. We should have some kind of mechanism to slice those blocks and resolve forks if there are any, So it will be like mini consensus in there. But it will be completely dependent on the main runtime and what farmers decide. So farmers control everything, but there is still a piece of logic that will have to be there on the executors as well.
So like that set of transactions that we called like the opaque transactions that the light client gets or that the farmer gets, those effectively are going to get sent like by the substrate client, at least the way I'm imagining it right now. The substrate client is going to act as a bridge that's going to send that opaque transaction set to the executor runtime or the executor consensus engine. And that's going to be the block effectively. Yeah. Like we might have to like construct some kind of like dummy block header or something like that. But that opaque transaction set is the extrinsic set that's going to eventually get processed by this second runtime.
Yeah, so we want to have those transactions like separately processed on the separate runtime, but at the same time, we do not want to reinvent the pallet balances and pallet contracts and any other pallet you might have. We just want to reuse them as is. So we need to prepare an environment which looks like standard substrate environment for them, like a sandbox.
So my current understanding is that so when the farmer propose an initial base block, it just doesn't process all the transactions, but it will propose like a regular block like before. Just doesn't process the transactions, and then it will send this like base block to the executors, and then the executors will process all the transactions, and produce the ER like they need to produce something. They have done the computation, the state transition is done, and then they will send the results to the farmer, and then the farmer will process the computation results. They need those results to finalize the block.
No, there's no block finalization. There's basically
okay. I mean finalize block. I mean to calculate this data to finish this block.
They're still going
to really produce a block. No,
they're not really. Well, maybe it's terminology we're using here, but from the farmer's point of view, the block is produced. Like from the runtime of the farmer, the block is produced. Even if there's no executors, like if there was no executor on the network, the block would get produced. But when the executor receives this block, they're going to take the blob, run it through their runtime, like the transaction blob, run it through their runtime, produce an execution receipt, which is a transaction itself from the farmer's point of view. That's going to wind up in the farmer's mempool. The farmers then, the next farmer who mines a block is going to, or farms a block is going to take that transaction, put it into their block.
Okay, this is my confusion. How is the entire lifetime of a block from the farmer's point of view?
Farmer just gets transactions, put them into block, and moves on. It doesn't wait for executors to do anything. So farmer can produce like 20 blocks, and executors produce 0, and it's fine. From farmer point of view, consensus is working, and everything is good. But then later, executor can come in and process 20 blocks, submit 20 execution receipts, and that will be included by the farmer into the next block. So we like completely separate them such that farmers are not blocked by executors in any way. It's just that if you like want to send me some tokens, you will not be able to know if tokens went through or not until executor comes, but it doesn't prevent farmers from producing blocks in any way.
Then how can I be ensured that a transaction is finalized, like it's confirmed?
Right. You need to wait for executor to process your transaction and for receipt to be included in the actual farmer's block.
Or you can run your own full node and do it yourself if you really want to.
Yeah.
Hey guys, so I'd love to continue this discussion, but we need to take a few minute break before we go into another hour-long meeting.
Okay. Okay. So this is my confusion for now.
Okay. Okay, cool guys. We'll see you in 3 minutes on the next call.
See you.
Thanks everybody.
See you guys.
See you.